Everybody, working title a bit. I've not done this one before. I'm going to sit because it just seems convenient. So we'll just treat it like a lounge conversation. So we can be casual. You can feel free to ask questions, right? It's a small enough group, and we'll just work our way through it rather than try and do it lecture style. So what is this title about? Do you need a dispatcher? So I work on Brighter. So I started Brighter. It's somewhere around 12, 13 years ago. And right now I think there are about 6 core contributors at the minute actively working on it. We've had lots of people commit over time. Handsome has even got a commit somewhere in the history, Scott Handsome. Mass Transit is probably the most popular messaging framework out there, one that everyone knows. Mass Transit recently announced it's going commercial from its next major release. We won't. People always say, "Oh, everyone says that." We will remain OSS. Part of the reason is we have a very slightly different format from other people how we do contributor license agreements. So there are 2 alternatives when someone commits code to an open source project. One is to say all code belongs to Ian and you waive all your rights, and Ian now owns it, right? And it's his copyright. We don't do that. So what we do is say, your code contribution remains yours, you just license it to our project in perpetuity. That means it's a sufficiently unclear title that it would be probably very difficult for us to say we intend to go commercial, because who's making that decision, right? Everybody owns the code. Rebus at the top, some folks use, and Wolverine. The other thing is that a few of us, and certainly Brighter, I think, Wolverine and Mass Transit can also be used in process. So Mediator, which is not a mediator, it's a dispatcher. Mediator is also going commercial, but most of us, not Rebus as far as I'm aware, but most of us can also be used to replace Mediator. So one of the questions I think people were asking when Mass Transit made its commercial announcement is, what we're going to do. We're going to move, we're going to stay on Mass Transit. And I get regular questions from people now at conferences saying, hey, we want to move to, we're thinking about Brighter and stuff like that, and we will probably come out with a migration guide, and we're probably going to release pretty shortly some tools that help you basically read and write Mass Transit messages so you can integrate us along with the rest you can make a slow evolution. But no discredit to them, right? Mass Transit, presumably for whatever reason, felt the need to turn it into a business. I guess you can figure out that if a certain number of existing enterprise customers are going to pay, that'll generate enough money for you to be a viable business, even if you lose everybody else, right? So no discredit to them. But the other question people, I think, were asking, and this isn't intended to just be a pitch for you to switch to Brighter. Some other folks basically said, oh, well, why do we need these tools at all? Right? That's a question I see coming up, saying it's much simpler just to not use Mediator. It's much simpler not to use your own messaging framework. Why would you use them? So I thought probably that meant it was a reasonable time period for me to go and talk about the why of these tools. What do they exist for? What problems are they hoping to solve? Knowing that, I think, helps you make better decisions about whether you need it, because you know what problem it's trying to solve. And if you don't have that problem, it probably isn't necessary for you to use it, right? That's me, I'm old, don't worry about it. And I just throw these slides in everywhere normally, and obviously I work on Brighter, so. All right. So what we're going to talk about? We're going to talk about commands and queries. What are they all about, right? And I won't labor how do you write a command pattern object or anything like that, but we'll talk about what they're for, why you might want to use one, right? Why not just put everything in line in minimal API or whatever and be done with it, right? We'll talk about command processors and dispatchers. So if you like upping your game one level from commands and queries, why you might want to do that. We'll then get into message pumps. We'll explain, actually there should be another title in here. It's the first time I've done it, so I've missed it. There should be one called Guaranteed at least once, which talks about basically why you might want to use messaging as opposed to just doing everything in process. Message pump, which is a key part of that. Commands versus events actually is a bit earlier. We'll talk about commands versus events. We won't do reactor versus proactor because this talk will be much too long, and then we'll do a bit of a wrap up. So this is generally a bit of work. So it's the first time I've given this talk, so you're going to see some bits that are probably a bit gnarly when we do it. So this is the classic command pattern, right? So what are patterns, in case folks don't know? So patterns sometimes get a bit of a bad name, but really, a lot of software there are solutions people have discovered to doing things. And if you have that problem, you can search for that solution, and it may give you a clue about how to solve the problem. All the LLMs basically do is pretty much say, whatever, I'm going to basically parse my way through the request that you've made, figure out what pattern applies to that, take that pattern, craft a response which uses the question that you gave me and spit something out at you, right? That's mostly what they're just doing, right? So the human beings tried to do that at some point by identifying common design patterns that they saw solving problems. So the command pattern is about separating the client, the thing that wants to execute some particular operation in your application, your domain model, whatever you want to call it. Separate the client from the actual code that does that. And what it says is, my client essentially is going to create a command. So you see there's a interface command, just has an execute method, concrete versions of them, so you have potentially multiple commands in your app. The concrete command is basically says, I am going to effectively enable you to execute the domain in some way. And the receiver is effectively saying, all right, what I want going to do is execute on the receiver some particular action. So in other words, it's a way of saying, please go and carry out this request for me. Ignore the bit to the left a minute. So what happens is the client says, I knew up a command. It may store a command in some kind of invoker. That's a bit of a sophisticated case where effectively we're saying, okay, I'm going to separate who does the invoking from the creation. But you then basically, the invoker calls execute, and the execute on the command calls the receiver, right? So the invoker issues a request called execute, and effectively you can begin to think about interesting things you can do with that. So one of them is, because I've issued a command, I know what operation I carried out. Therefore, I should know how to reverse that operation. So in theory, as soon as I create a command, I also implicitly know how to do an undo now for that operation. So what does a command look like? Something like this, right? So here we're imagining an idea of a place order command where we're saying we've got some order for a quantity. Like all examples we use in talks, it's very stripped down because you'll see we've got some that get a bit more complicated later and it gets hard to read, right? And we're trying to reduce to the minimum we need. But imagine I had something where I just need the product ID I'm purchasing, the amount of it I'm purchasing. I check that the stock's available for the order. If there's no stock, I'm going to throw an exception and say we're out of stock of that item. Otherwise, I'm going to save the order in my repository, right? So the command performs an action for us. Notice it doesn't return a value. It's fire and forget. Performs the action, does the work. The only kind of return value, if you like, is it can throw an exception, which basically says I failed. Right? So yeah, I mean, we are using the interface here, even though we're not necessarily saying there are multiple commands. We still might use an interface. So interfaces get a bad name. People say, "Oh, you should never use an interface unless there are 10 of them," right? And it's like that's rubbish. Interfaces can be used to indicate a role. So there's a thing called responsibility-driven design, and the idea is that my objects exhibit behaviors. They have roles in my system, and I indicate that role via basically interface. So I'm saying I'm playing the role of being a command in the system. So I've got a place order command, and effectively I'm going to go and do some particular execution. Here again, we're just taking concrete dependencies on order repository and stock service. You might choose to take an interface if you wanted to replace it for testing purposes with a in-memory or a fake, right? I tend to prefer in-memory versions to mocks, where if I want my test to run fast, you can use the real thing, that tends to make your test slow, but it's your choice at that point. Right. Yeah, and it's basically pretty simple CRUD. So it looks questionable. Why would I want to do this, right? Because you might just say, well, Ian, isn't that the same? Doesn't that do the same thing perfectly well, right? Is my minimal API call, and effectively it's just saying, hey, place order, sorry, I'm getting ahead of myself. So that's what it would look like in minimal API if I actually then make my called place order command, execute it, and get the results back, right? You could have some registry of commands where you're looking that stuff up, or you could even in basically doing DI around your commands, you want to get sophisticated, but that would just do the job for you, right? That says basically when I receive an order, my orders endpoint gets hit with a post, put out the product ID and the quantity off basically, it's not quite written quite right, off basically the URL, and then essentially get those two services and call my place order and then return a result. You notice basically you might question, I don't know, I thought I had a thing on there. Where does the order ID come from in return value? We'll come back to that. So one just inline the code, right? Isn't that the same, doing the same thing? Why has this effectively helped us at all to put that into a command? And I think this is the kind of heart of people's question at the minute, saying, well, why do I need mediator? You know, if it goes commercial, surely I just use minimal API and I inline everything. That's just as good. Okay. So one of the first benefits we get from separating things out is separation of concerns. So we say, well, hang on a minute. There are two concerns here. One is about dealing with web requests, returning values, codes, serializing my response into JSON or back, etc. That's everything to do with the web. So that's a separate concern, really, from I'm exercising my domain to find out whether I've got enough stock and I can place an order, right? These are two separate things. So maybe I want to separate them. Back in 1975, the fundamental theory of software engineering was declared by Jordan and Constantine, and it basically says, for any problem, if the parts are separately solvable, it's always more efficient to solve them separately. In other words, because these two things represent different concerns, it may be much more efficient to solve them separately because they're not coupled in terms of change. So I can change how I basically decide to raise new orders without doing anything to my API endpoint. That code remains untouched. Because the code remains untouched, I don't risk introducing defects to it. Right? So by separating those two things out, I effectively say, well, this one that's stable shouldn't impact this other one, and vice versa. If I want to change how my return codes work or what I'm serializing, I suddenly realize that JSON was a mistake and I'm going to serve XML in future. That effectively, those two concerns don't impact each other, right? So modification and replacement, and you can even see that if you decided to switch between a MVC style controller, right, an old classic web API for minimal API, but if I've got commands, it's a pretty trivial thing, right? We have code still at Just Eat Takeaway that was written with Open Raster. Anyone remember Open Raster? It's a bit of a nightmare if effectively the code's inlined in Open Raster, because you can't just say, oh, I can take the body of commands, I can take the domain model, I can extract that and just put minimal API over the top, and Bob's your uncle. I've modernized my whole app. Right? And while that may not be such a problem for people when they're working with like 4 other people and they've got 10 endpoints, we ship currently, I think, about 3,200 components. Right? At scale, it becomes a problem. Because the idea of saying, oh, we need to move away from Open Raster and etc., it becomes someone with a spreadsheet, right, figuring out the 200 things that need to change. So the other thing is that conceptually, what does a command represent? So those of you, how many of you are familiar with use cases? Okay, yeah, most of you. So use cases are kind of what happened before user stories, right? They're basically Ivan Jacobson, and they're a way effectively of us telling a story about our domain where effectively usually an actor does something in our domain, often with other objects within the domain, and that may effectively result in some kind of impact for another actor in the system, right? and generally just consists of a series of sentence-like statements that we make about things that happen in the domain. When we think about our domain and how we're going to model it, a command forms a useful idea in terms of modeling a use case. Right? We can say this command represents this use case, this thing that an actor wants to do in our system. They're often transactional boundaries. We often say, okay, this use case needs the transaction in the preserve invariant sense rather than necessarily a specific database transaction. But the whole thing must complete, or in other words, we get to the end of the use case and effectively we must satisfy basically the property that essentially we are in a consistent state at the end of the use case. So they're very useful for thinking about use cases, and particularly we also get into this problem where you may get reuse, right? Use cases are often reused in different scenarios. You may find that you get some other workflow that uses a portion of a use case, and so you get some reuse. Test isolation. So the other thing that tends to happen when people move towards a command-based model is they typically then move towards testing at the command. Commands are nice because if what you want to do is test your system's behaviors rather than your class's methods, and I would advocate that you should always be testing your behaviors in your TDD practice or whatever you're doing, right? There is no real separation theoretically between Kent-Beck TDD and behavior-driven. They're the same thing. You go and read what Ken wrote originally. So if you want to exercise behaviors, well, those are commands in the system, right? So you can say, I want to test this command. And then the interesting thing about that is that when you write tests at that level, your domain model becomes an implementation detail you don't have to write tests over, which means you can refactor it easily. So under that model, your commands form kind of a facade over your domain model, which is the point at which you do testing, which gives you much more flexibility. And you don't have to basically mock out minimal API or anything like that, right? The other thing that I think people also miss is that there's a whole lot of other stuff that happens in real examples, right? When we look at that, that's generally not the code we actually write. It looks very good in a tweet when we say, I could just write this instead, or even in a 10-minute angry rant saying, no one needs mediator, look, you can just write this. That isn't what we actually write. We tend to do things like use poly for resilience. We tend to basically put in statements around logging or observability and things like that. We might do validation, right? So after a while, if I'm putting all those minimal API endpoints into my program CS file, things are going to build up pretty heavily. Even in the days when I was doing Web API controllers and I've got a whole lot of inlined methods operating on the resource, things get pretty gnarly quite fast and you get big DI components. So actually splitting that out kind of helps. So one of the things this helps us do is implement ports and adapters architecture. So ports and adapters, sometimes called hexagonal architecture, is kind of the granddaddy of things like clean architecture and onion architecture. It's actually much simpler than any of those. It doesn't require DTOs, doesn't require multiple layers. It just requires, there's the app, which is kind of like plain old C# objects focused on my domain. There are some ports which let you basically send messages to that particular app and drive some things outside like databases or message queues. And then there are a whole series of adapters that basically call those ports. We'll show you a diagram in a minute. But if you look at, oops, what happened there? It's interesting. I don't know why I did that. I found a new key of some sort. If you look at this placeholder command, right, this is perhaps slightly more realistic. So you can see what we're doing here at the top is we are essentially saying, okay, I'm going to define a poly policy for resilience where I'm effectively going to say, I'm going to retry this one 3 times. I'm going to basically jitter my retry attempts slightly. And if I run out of retries, I will basically indicate that this thing failed, right? And you probably actually write that to someone more useful in console write line. And execute async, right? I'm actually going to say, you know what? This is basically probably a new span. I'm going to effectively start a span for this operation, which effectively will shut down at the end of basically this command, so I can neatly encapsulate that behavior, set some tags on my span, so I tend to want to be able to understand my business logic. So here I'm marking down effectively things to affect the operation. I'm then going to execute it inside this policy, and then I'm going to do my operation. I haven't even added things like validation here, right? All I've just added in basically, oops, lazy, is just some resilience and some telemetry. But you can see that's got a lot bigger. And if I was trying to inline all that into my program CS file and my minimal API, that's going to get a bit long, right? Encapsulating this as a command means, in a sense, I can say, well, you know, actually, I'm going to encapsulate all of those orthogonal things inside my command and execute my domain model. So it can hold all of that orthogonal stuff, and then effectively down below, I will call the domain model to actually exercise. All right, we'll come back to that a bit later. This is a hexagonal architecture for those of you who've never really seen one. Who's not seen ports and adapters architecture before? A couple of you, all right. So ports and adapters, so app. So app means probably to you and I domain model. That's basically Cobin's term. That's the application. It's effectively plain old C# or whatever language you're using. Doesn't do any I/O, doesn't talk to the outside world, just exercises your business logic. On the left-hand side, you have what we call driving ports. So they are things that effectively call exposed interfaces, which offer functionality to the outside world, right? So here you can see we've got interface that Lollipop says for using, one for configuring, and one for admin. So we're saying we've got one set of interfaces into our app, which basically say things like, hey, I can place orders or retrieve orders or cancel orders or whatever. One side which is configuring, like probably things like, hey, add a new product or whatever. And one side for admin, which may be for whatever, you know, whatever I need to do to admin. It's like, hey, set up a new user for the system, whatever. Doesn't really matter. So you can have different kinds of adapters. So we might have minimal API, our using statement. Actually, the configuring stuff is all done by command line tools. So we're just going to drive with Spectre console, and the admin stuff is actually Razor pages that we expose directly. We can pick whatever kind of adapter we want, and we can swap them in and out, right? So the idea is we're not coded to care about what our choices are. Boss comes in one day and says, screw it, you know, make the admin interface Blazor instead, right? It's fine. You just spin up a Blazor app and start calling the exposed admin interfaces instead. On the driven port side, similarly, our application may result in outgoing I/O. So it may write and store stuff to a database. It may send a message over a messaging framework like AMQP, like Service Bus. It may write an event stream to something like Event Hubs or Kafka, right? Notice that unlike Clean or Onion, there is just inside and outside, right? There are not layers of DTOs that I have to create and all that kind of things. There is just the app with plain old C# objects and this kind of facade which says, I'm going to let you effectively perform some operations on the inside. And it's not specific about how you create those interfaces. But one argument is that you can use a command to effectively provide that interface, because this stuff was written at the same time as people were very into use cases. There's a thing called the boundary controller and entity model from Jacobson, which effectively is what this model implements, which is designed for use cases. So your use case effectively has this idea that says, my actor effectively calls one of these operations, which results in an outcome. So typically, what we're doing is saying, well, I can drive my app, which consists of commands. I can test basically those commands, right? So my X unit can just basically fire at that. Probably that means I can pretty much say, well, I can skip I/O mostly. I'm just exercising my app, and I could basically put some in-memory objects for driven ports because they're all just adapters I can swap in and out. As far as I'm concerned, it doesn't matter whether it's Postgres or MySQL or SQLite. I don't care, because I'm building it deliberately to be able to swap those things in and out, right? So you can exercise those commands via X unit, and that becomes the point you test. which makes a lot of your app implementation details of those commands, which is very easily refactorable. Okay. So we also get into command query separation. No, there's no responsibility in this yet, right? This is basically very old school command query separation. There's a classic principle in OO design, which says asking a question should not change the answer. In other words, when we think about methods on a class in its original form, it's a method should either mutate state and not return a value, or it should query for a value but not mutate the state. That makes it very predictable what an object's going to do. There are a thing called no side effects. If I query you and that results in you being changed, and then I query you again with the same parameters and I get a different result, that makes life very difficult. I can't cache things, for example, when that happens. So typically we don't want that to happen. We want same parameters, same query, of assuming no operation that happens in between, result in the same result, right? I should only get a different result if in between I make a call that mutates the state. Right? So that's command query separation. So you can think about commands. Remember I said they don't have a return value, right? As doing something, but not returning a value. And then there's that question of, well, but when we looked at that minimal API earlier, how the hell did we get hold of the order, right? So what is basically giving us the order? And the answer is a query. So a query is kind of like a command, but it's going to return data. So a query looks a bit like this. It says, what I'm going to do is call a query called getOrderById. It's going to say I'm a query. But whereas I'm a command didn't specialize its type, I'm a query says, actually, I'm a query of orders. So the execute async is going to go to my order repository, find by the order ID, and just give me an order back. So now I have a kind of like a command, very similar in terms of the pattern that I'm using. Like there's a thing where I call an execute on it, and I encapsulate my ability to interrogate my app. But in this case, I'm going to return a value back out. Okay, yep. So that ends up with something that looks a bit like this, where effectively what I say is I'm going to create my place order command, I'm going to execute it, I'm going to go and get the order by ID, I'll come back to the return order by in a second, then I'm going to execute that will give me an order, and then I can basically return the results. So I make the change, and then I basically retrieve the what the change looks like, right? Now interesting, you see it says place order command, return order ID. So there are a couple of options when you use a style like this. In theory, the very correct style is you use something like high-low or a UUID, a GUID, right? And you basically say the identity of the order gets generated here in the minimal API thing. I basically say, create me an order, and I pass it a UUID, and that is my order identifier. Even if you have an internal identifier in the order, which basically is some kind of incrementing ID for clustering, right? You would say UUID or a high-low value, so I know it from the outside, so I can then basically just query that value. Often it doesn't work quite like that, right? You find yourself, I want to return a long value, so we just cheat, right? On our command, we just basically say, okay, one of the properties of my command I'm going to call return order. I think of them as out parameters, and effectively I can query that afterwards and I'll write it in. So we're sneaking a return value back in the thing that we're called with, kind of like an out parameter. It's a cheat because we're not trying to mutate state, but we return a value to indicate, hey, you may need to do another operation, and I'm going to signal to you what that is, right? So it's just a hack, but worth knowing about, because Brighter works this way and people get confused, they don't understand. You just use return value and out value. All right. So CQRS, or command query responsibility separation. So where the CQRS comes in. So once you basically accept the idea of commands and query separation, and you say, I've got a command object and I've got a query object, and the command object basically exercises some use case in my domain which results in mutation of some kind of state, and my query object retrieves state. You may say, well, hang on a minute, all that stuff with repositories, typically underneath in the repository I'm implementing with something like Entity Framework Core. I may, if I'm lucky, just be on DAF or something instead, or I might be even using something else entirely. The trouble with that tends to be it gets quite complicated. I'm trying to optimize loading strategies. I'm trying to figure out eager loading and lazy loading. Where does my graph stop or whatever? And that gets quite complicated. But it turns out that you probably don't want to do that complexity, because that complexity around ORMs typically only happens when you're querying them with a whole set of parameters and selection and everything else. When you're writing and doing commands, mostly what you'll tend to find is you get something by ID and you mutate it and you save it, or you create something with an ID, right? You may, in what DDD calls an aggregate, get something by ID that forms the head of an object graph and get a few other objects underneath, but generally you're just getting something by ID. Right. And that's a fairly simple model. You can basically model easily in your ORM. On the query side, well, you may just want to query directly using whatever syntax. So here, SQL, but you can do the same thing if you're doing DynamoDB or whatever, just basically, or just use its query syntax. We're just going to use the query syntax directly. There's no need for the two models to be the same. Command query separation means we know this isn't going to mutate the state. It's just doing read. Absolutely fine for us to do direct SQL. And that's what all CQRS is. It says, simplify the models by making this a model that basically cares about how I read stuff, and the other model a model about how I write stuff, and don't mix the two models together and your life will be a lot easier. So I was kind of there when CQRS was created by Greg Young, and the whole, in a pub in London actually, because all the greatest things in the world were created in pubs somewhere, right? This is the whole problem we were trying to solve originally, was the whole lot of us using nhibernate as an ORM, and the problem became that we ended up with various attempts to basically query nhibernate to get data back, which effectively then had to live in what's called an identity map, which says, hey, I've retrieved these rows for you, I'm going to store them in memory, so that if you ask them again, can they possibly mutated, you're going to have those rows back. ORMs get quite complicated, right? And we just said, hang on a minute, wow, we don't use the ORM for just doing retrieval. All that complexity drops away. The only time you start caring about identity maps are for your commands, and generally they are a fixed operation with a scope. I go in, I create something, I save the state, I dump it, I'm then done. That's where this idea of a unit of work being allowed to a command comes from, right? So you're just doing the one thing, like your unit of work, I'm done at the end of it, other side I'm going to query by SQL. And that's what CQRS is. It's trying to simplify both sides of the equation. So I understand people out there kind of like, we've lost track of this a bit because event sourcing came in. Event sourcing has nothing particularly specific to do with CQRS. CQRS enables event sourcing if you want to use it, but it's not part of CQRS. So people go, oh, you're adding all this complexity with CQRS. CQRS is designed to simplify. If you're using CQRS and things aren't getting simpler, you've done it wrong, right? The idea is to basically say, oh, there's a simpler way of doing my queries, so I'll use that. Okay. So basically we get to CQRS there. And this which is pretty hard to read, right? Doesn't really do very much apart from encapsulate a query that does direct SQL rather than calling a repository, provide some polypolicy stuff and some telemetry. But you can see there's quite, even though I haven't done all the things you might actually want to do, like caching layers, for example, you might want to use Fusion Cache and cache this stuff so that if someone basically makes the same request with the same parameters, you can determine whether or not actually I can just serve you your cached results rather than going to the database, etc. But there's quite a lot of complexity. But I encapsulating it in, if I was inlining all of this in minimal API, even a classic web API controller, it's going to get nightmarish. But I'm encapsulating it here inside my query object. So it's a lot. I've encapsulated that problem space. Interesting notion might be though, what happens if I want to perform validation? What happens if I want to check this is a valid product ID? Blah 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 blah. Right. So it gets cut very quickly. So Why might we want to use commands and queries? They encapsulate a use case, they align well with the ports and adapters of the port, they form a useful conceptual transactional boundary, they allow a point of reuse, we can reuse use cases, and they reduce clutter and things like minimal API. And they encapsulate orthogonal concerns like resilience and observability, and they separate concerns like easy modification and replacement. They allow us to reduce the cognitive load, right? So I can think about things one command at a time rather than everything at once. And I enable CQRS. But arguably, this is still messy, right? So you could say to me, Ian, okay, I accept maybe my minimal API endpoint doesn't need to be cluttered with all this stuff. But you've just created this internally cluttered object now, and that's still pretty difficult to work with. Right? So the next thing we're going to do is try and fix that. Which is where basically processors and dispatchers come in. So if you want to be smart, you don't talk about mediator, because mediator is an entirely different pattern. You talk about processors and dispatchers, because that's what they really are. What's the command dispatcher? So, all right, looking at the diagram as opposed to anything else. So the client is effectively going to do a couple of things. The first thing it's going to do is register a handler, right? So basically, it's going to register something that conforms to an interface, so I can register many of these things in a collection. Typically, I have a key which says look up this one rather than other. So I'm going to register a whole lot of handlers. And what the handler is that execute bit of the command, right? So we had in our command, we had an execute bit and we had a constructor that took some parameters. So the handler is just going to be the execute bit. And we'll separate that out from the command, the top, which will be the parameters. So we're going to separate the parameters from the action. And then when we invoke it, what we're going to do is we're going to say, okay, go and look up this command's handler. So here, in the original form of the pattern, crudely, we're just going to use it by key. We quite often use things like type, etc. But the key idea works. I'm going to look up the actual handler, and I will execute its code. Right. So I separated the two bits, the execute bit and the bit that basically says what are the parameters of this operation. And that's basically what that says. So you can kind of see a sequence diagram there. And we're saying effectively we want to separate basically the action request, what do we want to do, from the action handler, how do we do it. So one of the advantages of this kind of separation is, in theory, I can replace the action handler and it doesn't affect the code that makes the action request. Previously, in my minimal API where I'm saying place order command, execute, in theory if I want to provide a different version of place order command v2 or whatever, then my problem is going to be I have to write that coding in, right? But now what I can do is just say, okay, well, there's always place order command, and then I invoke my dispatcher to send it to it, and my dispatcher might call place order command v2, v3, v4, v5, or whatever it is I want to call it, right? So I can keep iterating through new versions of stuff I want you to call, and I may even allow, if I get really sophisticated, some selection between them. There's ideas like a thing called agreement dispatchers, which basically we won't talk about today in detail, but they let you say, for example, dispatch this, but depending on the date, to a different kind of operation, right? So, hey, old contracts basically follow these rules, new contracts follow these rules. Right? So that's what dispatchers kind of intend to do for you. All right. Another idea I want you to understand is a command processor. What's a command processor? So a command processor is the idea that I have some orthogonal operations, right? And I may like resilience, logging, and that kind of thing. So what I'm going to do effectively is I'm going to essentially pass my command to a command processor. So rather than call execute on my command, I will say command processor, execute my command. What that enables the command processor to do is to say, oh, I'm going to do some orthogonal things before I actually call your command. Logging, resilience, that kind of thing, right? So I can, remember we said, oh, look, here I've got some resilience with poly. Oh, look, here I've got telemetry. Oh, here I've got validation, right? Well, in theory, right, my command processor could do those for me instead. it could say, oh, well, before I run my command, I'll log something for you. Before I run your command, I will encapsulate it in a poly-resilient strategy that if it fails, I'll catch that and retry it for you. So the command processor says, I can lift those operations out of your command handler, or your command in this case, effectively, and do them elsewhere. So you can combine, let's get that slide, you can combine these two ideas. So you notice what I've done is a little orange line. What you can say is this, right? I can create a pipeline of handlers for my dispatcher. When I go in and I say, okay, I've got this command, we can say, okay, that command doesn't result in that dispatcher. That results in this pipeline of dispatchers, which effectively gives me my sink in the pipeline, which is basically where I exercise my domain code, and a whole lot of filter steps, which I can run first. Today, the usual word we use for that is middleware. So I can put middleware in front of the execution of the command. And in the middleware, I can do reusably things like run a poly policy, right? Start a new span for my telemetry and add some tags to it, right? Log this, right? So I can lift all that code that was cluttering my nice execution out and put it in middleware very easily, right? Typically, we use what's called a rationale model, or I'm going to try on a horrible Russian, but matryoshka. I don't know. Oh, there we go. Thank you very much. Someone actually had to set. Where effectively, the Russian doll is the idea. Effectively, you get a little tiny doll with bigger doll, bigger doll. So the idea here is basically you say, rather than doing a kind of linked list, what you say is this particular handler. One of the things it does is call the next handler in its execute, right? So I can do stuff before or after that execute is called. So typically, things like I can put a try-catch block around the thing, right? So if I can do a try-catch block or a try-finally block, I can do things like, I can therefore do a poly-resilient strategy. I can do something that says, okay, I need to clean up on the way out if there's an exception gets thrown. You can even say, if an exception is thrown and it bubbles past my resilience handler, call some fallback code that I basically have registered, which will form an operation to say, this failed, now you need to go and do this. So that pipeline is what your dispatcher gives you. So typically, if you look at something like the way Brighter works, I think others have a similar process. I'm not sure Media has a pipeline, but I can't remember. The reason we do it this way is because we get to combine both a command dispatcher and a command processor in one by saying I'm going to use my dispatcher, but I'm going to give you middleware. So my big win for using my dispatcher is less, I'm going to have an agreement dispatcher model and you can actually have different syncs that get invoked or whatever, or I'm going to replace this version of the sync with another version of the sync and no one will ever know at the call point. My big win now to a large extent becomes I can now put middleware in here, which effectively will remove stuff. So here, we've still got the telemetry in this one. We haven't removed that yet, but here you can see we've just removed the policy stuff. And so this is Brighter code, by the way, just because it's a reasonable example of how we do it. So we give you an attribute, you put on basically, and you say, I want to use policy, and we will figure out that means I want to basically run the policy middleware, and the policy middleware will look up basically your place order retry policy, which is effectively you've stored in your policy registry. We will look up and we'll run this in the context of that policy. We could add another attribute, which would basically be something like, use new activity, right, and give it a name. We'd start a new activity. You could have something like tag existing activity and give it a list of attributes to use, right? So that enables us to lift all of this orthogonal code out again into our middleware. It's reusable in middleware, so we can use it across many pipelines and simplify our code again back to the point where effectively we had this very clean model that we said was naive, but we can actually do now, right? One thing I'd be careful of, everyone when they see this, they'll go and effectively say, oh, for some reason Brighter doesn't provide a transaction scope. I'm going to add one of those. Be very cautious with that. One of the reasons we don't do that is we saw, when we used to have one, a lot of errors where people would not appreciate that they were starting a database transaction, doing a whole lot of stuff in the handler, which involved calling other microservices via HTTP or whatever, effectively, etc. So you're keeping this transaction open for a long period of time. So we dropped it because we said the trouble with that is you should be explicit about your transactional boundary in that. You can add your own, but you have to know, just be cautious of that problem space, right? But you can write your own middleware for Brighter, and it's so simply all you do is just implement a handler. You implement a handler and you implement an attribute, and the attribute just says what handler relates to this attribute, and you just chain them all together. You can see at the bottom of our handler here, we say return a weight-based handle async. What that means is effectively call the next handler in the chain. Right? And if you do that in different places in your code, you can obviously encapsulate stuff around that if you want to. This is the sync handler. It's effectively doing the final step according to domain logic. So there's not a lot of point in putting it higher up in this particular context. If it's the sync handler, what happens when it calls handle async? It just says I'm the sync handler. There's nothing to do. Just a no-op. All right. That's an attribute for handling, for creating, say, create attributes in Brighter. Very simple. You're just returning the type of the middleware that you want down the bottom. And that's what middleware looks like, right? There's a classic middleware for doing some logging statements, basically, that say, okay, you're going to get a command in, log something, etc. All right. Okay. So we've been talking a lot about commands, but there's also, and we talked about queries, and there's another idea you need to understand a little bit, and that's events. For now, we're going to come back to messaging. What we're talking about is command and events in terms of your app, so that inside that hexagon, right? We're not talking about them in terms of distributed systems. We like to overload terms a lot in this industry, right? Like service and process and whatever. What we mean by command and event here for now is basically what we've been describing so far in commands and queries. We're going to identify event in a similar context. So we've established a command mutates the state of resources or activities owned by your application. So generally, you can think about any given app owning two things. Resources, those are things that basically you are responsible for in the domain, like hotel rooms or car engines, or whatever it is your software deals with. And activities, which are effectively workflow state, right? So if I've got a hotel room and it has states like occupied, unoccupied, needs cleaning or whatever, in some cycle state machine, that's an activity, right? So generally, a command mutates one of those things. It effectively might transition my hotel room into a new activity state, for example, right? And that may do something in particular. It's a consistency boundary, so generally by the beginning and end of that, I shouldn't leave effectively in those resources and activities in an inconsistent state. A change may impact more than one object. In other words, essentially, it doesn't have to only implement one particular resource, maybe many. In domain-driven design, if people know about domain-driven design here, roughly, okay, yeah. So you basically, an aggregate is a consistency boundary where you think about a graph of objects, but rather than having to basically say, I need to lock all of them, perform some operation, unlock, to keep it consistent, you just lock the root, right? It's a simplification. That's what an aggregate is. All right. So an event, or in this case, what we tend to call it a domain event in DDD terms, says, I have modified this one consistency boundary. Others may care about the fact that I've done that. Right? So, I don't know, a random example, when my room status moves to unoccupied, maybe housekeeping gets signal to know they could clean my room or whatever, right? Now the idea is effectively, we raise it, and what we can do is treat it like a command or a query. In other words, we can say, oh, well, I've got a model already via my dispatcher for saying you've got something that has some state, and you want to effectively invoke some behavior when that happens. So I can just reuse that dispatcher model, and I simply give my dispatcher an event and say to it, go ahead and run that bit of code, which is the event code, which should modify another consistency boundary. Events effectively tend to have 0 or more handlers. In other words, it may be that actually, even though I'm raising an event, no one's using it yet. It may be that as well as housekeeping, the concierge knows that I've gone out today or whatever, and they listen to my room has become unoccupied event, all right? Typically, if you've got more than one, we tend to raise them on parallel. We basically don't want your main thread where I've just unoccupied to block. I'm unoccupied, but it spins off some other threads somewhere else that go away and say, oh, I better go and kick off some work for housekeeping and the concierge now that you're done. So here you can see what we're basically saying is, oh, well, when my order is placed, I'm going to publish an order placed event, right? So typically you see this correlation, place order command, order placed. So place order, order placed. One is basically an imperative instruction that says do something. The other is an event which says I have done that thing, right? So I'm giving it to my command processor. That's what Brightly uses as the term we use as I am a command processor, and effectively saying, okay, do a publish. So that's the term, Brightly uses the term send to mean basically for a command and publish for an event. Historical reasons why we do that. And we're saying publish that event, so anyone who basically is interested can effectively understand that an order was placed. Right. So, order placed event handler, right, says, okay, great. Well, I'm at the end of another dispatcher pipeline with middleware and everything else, and when I receive the order placed event, because you invoked me and called me, and that just basically ran another pipeline, I'm going to attempt to decrement the stock by the amount basically that was removed. Okay. So we're separating those two aggregates, those two pieces of work. Now, a question that may arise here, as you may say to ourselves, okay, but hang on, Ian, that's all very good, but what happens if my app crashes now, in between you having placed the order and essentially before I basically handle this stock decrement? Or what happens if for some reason I can't talk to the database or there's some DB failure, which means I don't get to decrement the stock? The first thing to say is often these problems are just dealt with as business problems, right? In other words, someone goes to try and get some item out of the warehouse from an order and turns out they're not on the shelf. And who knows if we actually, know exactly what's in the warehouse just because we're decrementing stock counters inside our code, right? That's the first option, but we're going to look at how durability kind of works and how we can avoid that problem. All right. So guaranteed at least once. So this is the point where we begin to think about messaging. All right. So messaging tends to rely on a queue or a stream, which is effectively stored somewhere. And I think of them as old school, like American mailboxes, right? Mail is going to sit in there until someone comes to retrieve it. And it's what we call asynchronous communication because both parties don't have to be present at the same time. Mail is a very good analogy for it, right? Your mail goes in your letterbox. You don't have to be home. You come home, you pick it up, and you read it. So that basically gives us a notion of guaranteed delivery. You will get it eventually, right? Whenever that is. So instead, effectively, of raising that event internally through the dispatcher, we can choose to basically say, actually, what I'm going to do is I'm going to put that onto a message queue. So in Brighton, we just give you an operation called post, and post says, take that and put it on a message queue. And what you've done is, in your setup your application, configured what is that messaging broker that I use, where does it live, please write it to that, right? Okay. And the advantage of that, then, is this, right? Producer gives it to a broker puts it on a channel, consumer reads it from the channel. Once that message effectively reaches the broker, it is guaranteed to exist, right? So once I run that second kind of, once I've made that post statement there, I'm saying, okay, I'm going to definitely have a message now, and that message is essentially going to mean the stock is going to be decremented. What we're going to do is make sure that when we read when we say to the channel, I've finished with that message, I've completed it, we only do that once we've completed the transaction, decrement the stock, right? So if we were to crash, Message will be left on the channel. Somebody else would spin up, say, oh, we don't seem to have processed that message. I better process it. And we'll keep trying until eventually we succeed, which is basically durable execution. Okay, I'll run through a few bits. So to produce our message, so we had that command we were handling effectively over to post async. I need to turn that into a message that's understood by end service bus, or not end service bus, a service bus on Azure or SQS or RabbitMQ or Kafka, whatever I'm using. Right. So typically it's a transport protocol. It has some very different way that it writes stuff. If I want to support multiple transports like Brighter, I might do an intermediate format which says turn this command into a message. Here's our generic abstraction for a message. Hand that to the transport which turns our generic abstraction of a message into something on the wire. That's what we do, so we can basically separate our headers and body and metadata and that kind of thing. Typically it's a thing called a message mapper, which basically says take my request, turn it into a message. Brighter is about to release V10, so it's out. There's a V10. Currently out is 10.00 preview-6, very chips off the tongue. We're calling it RC1 at the minute. We'll probably put something out on social media next couple of days. So we only increment. So we're currently version 9.910 is the main version you want to use. We go up a major version number. We use Semver only when we introduce breaking changes to the interface. We only do that about once every year to 2 years. We kind of save them. We try and avoid doing that unnecessarily. We may make minor version increments. In other words, we make additive changes and provide suitable defaults. But every so often, things kind of accumulate and we need to make a big change. So it turns out soon, much better support for telemetry, much better support for cloud events, some clarity around how you configure interfaces, particularly between sync and async pipelines, etc. It's RC1, it means effectively that that's the first time we're nearly feature complete. There's some stuff still to go into RC2, but we want to start testing it and squashing all the bugs, and there'll be loads of bugs, right? But one of the changes is that we forced you originally to write a message mapper for every command that you wanted to map to message, to write an individual mapper. What happened is most people end up just saying, oh, just JSON serialize my body into the body and just use the normal headers. So we've just given you some defaults you can use as a generic. I just want to use the default mapper for JSON or the default mapper for Avro or whatever it is you want to use. All right. And again, we also create a pipeline, a middleware pipeline here for transformations that you can do. I don't know if any other frameworks do this. So we have a transformation pipeline that says, you create my message, but actually it's big, so I want to compress it or use a pattern called claim check when I put the content actually in S3 and you retrieve the content from S3 on the far side. Or I want to encrypt it because it's got sensitive information inside it, right? We put that stuff basically what we call a transformer, which means you can mark up your message mapper and say, actually, I'd like to basically perform these additional transformations on my message as it flows through. So it looks a bit like this. Command processor, basically, when you say post, says, okay, load up the relevant message mapper, serialize the message into our format, run any transformer that you need to transform on that transform message for middleware, for like compression, claim check. Then attempt to call the producer, do that inside a poly resilient strategy, basically in case I can't call the producer first time around. Right, which gives us that. But you may say, Ian, hang on a minute, I can see a problem. You say effectively you're going to send this message, effectively when we basically place the order, but what happens if that resilient strategy says retry 3 times and you fail? I've updated my database to say the order's placed, but you haven't put that message on the queue, which is going to decrement the stock. So that's where this idea of transactional messaging begins to creep into our lives. All right. So transactional messaging says you have to ensure that for an entity change, where I want to basically make a corresponding action downstream, there must be a transaction which encompasses both making that change to the database and sending my message. Right? And the problem a little bit is that we don't live in a world where there is a distributed transaction coordinator usually available which controls both. Often they're from different vendors, completely incompatible. In some cases, they might be from the same vendor support transactions, but even that's rare nowadays. I think MSMQ and MS SQL are about the only things you could do it with. All right, which is why, by the way, interesting enough, Mass Transit and Service Bus didn't start life the same way. So Brighter always started life as a framework for doing messaging, but they started life as brokers because they were brokers built basically for people using MSMQ. So that because MSMQ had transactional integrity built into it with a SQL Server. So in the Microsoft space, people using MSMQ plus SQL Server had a nice messaging strategy, but they had no broker. So both Mass Transit and Service Bus originally were brokers for MSMQ. So only later they become frameworks. We were a framework much before that, long before they were, because we used RabbitMQ from the get-go. We ignored MSMQ. Right, so you've got to have some other strategy than MSDTC. So what do you do? So the outbox pattern is fairly straightforward. What we just say is, okay, rather than sending the message, I'm going to write two things to the database in the transaction. One is the change to the entity. The other is the message I want to send. So remember we said we do a whole bit of work where we turn you into an intermediate message format. That's what we're going to store. We're going to store that intermediate format in basically the table, right? And because I can have that as a transaction, this tends to be called an outbox table, right? I can say either I wrote the message and made the entity change or I failed. Now, that message now sits in my outbox table. It exists. It corresponds to what happened. I just need to send it. Two options. One is you can probably just, you may have a method in your we do in Brighter that says you can just send this immediately if you want to, right? We let you immediately send, just write some line of code which says send stuff directly from my outbox. The other is you basically have some separate running process, which we tend to call it a sweeper, that's running in the background, says keep looking for unsent messages in my outbox and send them. Typically you can't do both. If you want to do the immediate send, you typically then also rely on the sweeper, because if your immediate send fails, you don't care. The sweeper's going to pick it up for you. And sweeper will just keep retrying until eventually it sends it. That's why we call it guaranteed delivery, right? So it just keeps retrying them until it's sent. Right, and you can also send a message immediately. Right, now, the only slight problem is if the sweeper comes along and it says, I failed to send that message. Did it? The problem is you can't necessarily know when you sent to a broker whether or not basically you sent it or not. And why? Well, typically the way a lot of brokers tend to work, RabbitMQ, so Kafka works this way, is you get a callback a bit later. So the callback typically comes to you when it's propagated that message to all of the nodes in the cluster. And if you fail to get that callback, it doesn't mean it didn't propagate to the cluster. All you can know is you failed to get the callback. It could have been a network blip that basically meant when it sent you the callback, it failed, right? It may have propagated to enough of the cluster that things downstream could actually work. It's just that one of the nodes didn't work, and maybe it's about to be taken out of commission anyway, but you can't know that. So the problem is your sweeper, because it can't tell the difference between those, may end up sending a message more than once. Because it may say, I sent it, but it isn't marked as dispatched because I've had no confirmation. So after a certain amount of time elapses, you may say, oh, well, I'm not sure that's been sent, you know. So you know what, I'm going to resend it. So the only way to be guaranteed is to be at least once, right? So we make this promise, which is guaranteed at least once delivery, but I may send it to you multiple times. And in distributed systems, there's just no way around that. So you'll hear people talk about guaranteed exactly once, but it's a trick, and we do that too. So the trick is you treat what's called an inbox, right? You just say at the other side, you record messages you have seen and you discard them if you've already seen. If you're idempotent, you have to do that. If, in other words, basically, essentially, you could have that message run n times, and it would always mutate the state in the same way, and you don't really care about the redundancy of doing it, you can just ignore inboxes. You can just go, whatever, it's only going to make the same change, right? One way to do that is if you have versioning for, say, the upstream, so you say, well, the upstream is now on version 16 of this, and downstream you have a model which is called apply only if later. Then you say, downstream you record, I've seen version 16. When I receive version 14, which is a duplicate, I just ignore it because I'm already later, right? Okay, but otherwise you basically need an inbox, and the inbox kind of says, oh, well, I've already seen this one and completed that action, so I'm not going to do it again. And that's idempotence. So again, a bit hard to read because they get big, but you can see here what we're doing is we pass in the constructor, I've got a mouse, this parameter here is an I am a transaction provider. So while we pass in that in, so we need to know as a framework what your transaction is, so that we can write to the outbox for you with the message. So we have to agree that's how you're going to create your transactions, because we know about that and you know about that. And so when we implement outboxes for things like Entity Framework Core, for example, you set it up at the beginning, and we therefore agree to share the same transaction provider as you. So basically, it's a parameter that you have to just to add the parameter. If we register it all for you, you just need to know I need to use a transaction provider, and then basically I need to create a transaction using the transaction provider. So don't do it more directly. We under the hood will call Entity Framework or whatever it is that you're using to create the relevant transaction. Then effectively you save your work basically to your repository or whatever, and we are effectively going to, when we do called deposit post, so previously we called post. Post, by the way, someone asked me why is it called post? Because it's either putting something in a post box. Right? So post basically encapsulates both the first method. If you don't really care about this, it encapsulates both these operations, deposit and clear. And it's basically for scenarios where you don't care about transactionality. But we're going to deposit post, in other words, put my post in the post box. We will get back an identifier for the post you put in the post box. We just store that in a list. Because we could be sending multiple messages. Commit the transaction. If that transaction commits successfully, we'll pass through the catch block. If it fails, we'll throw, right? And we'll unwind the transaction. And we won't have written either that message or that order. If it commits successfully, we're going to do an immediate send. And we're just going to call clear outbox with the post. So we're saying, go to the outbox, flush everything with this identifier of message, the ones we've captured earlier, and send them immediately. Right. So, and we also do show you in Brighton, what I showed today, how to set up sweepers and stuff like that. But sweepers tend to get in the world of locks. You have to have a lock to basically say, I am the sweeper that should be running, as opposed to all the other sweepers that should take over in the event that I stop running or whatever, right? So that's why I won't show you that today, because it gets a bit complicated. Right. And our order processed event handler, right, can just be in the receiver of when you read that message. So now it's occurring over a message queue, but essentially when it receives it, it's effectively just saying, oh, okay, now I'll exercise my code. Typically, it's going to be in a separate process. We'll explain why a little bit later, but typically because you're going to need to run a message pump that basically gets things off a queue and actions this stuff. All right. Oh, yeah, and it's got an inbox on it. I forgot to show you that. So that statement, use inbox, says basically use an inbox to deduplicate things that I've seen before. And it's just using our middleware pipeline. Because this is a dispatcher, we can put stuff in middleware, so we're going to use our middleware pipeline to list out the orthogonal operation, basically, of doing that syntax. Right. So it looks a bit like that. So our command processor calls a message mapper to turn your command, your event, whatever it is you're raising, into a message. Runs it through a transformer pipeline in case you have anything specific you need to do about, PII or whatever. Stores it in an outbox, and the sweeper, we're showing it simplified to show it this way rather than show immediate send as well, says, okay, go to the outbox, read those values, and then call the producer using some middleware to try and make it more successful. So essentially, one of the things that's interesting to see here is we are utilizing the dispatcher that we've written to effectively get some of the resilience and stuff that we need. All right. Why don't do this yourself? I mean, in theory, you could basically write some code to produce a message. It's not hard. You spin up a Kafka client or whatever and write produce message. It's not particularly hard. But it won't give you basically an outbox out of the box, right? So you won't be able to do transactional messaging. It won't give you an inbox out of the box for duplicates. It won't handle common transformations for you. All this stuff is the value add that you'll tend to get out of using a framework rather than writing it yourself. Right. So that event handler we saw when we're receiving the message, how does that work? So what you want to do is essentially, that last point probably should be animated, but here we go. I want to turn that event or command that we send over the message queue so it's in some transport format, right, for Avro in Kafka, or it's some sort of UTF-8 bytes in Rabbit, right, back into a command or event, and then just pass it to your handler. So the same way that in MVC, I don't really have to deal with the HTTP gubbins, right? I just write API endpoint in Minimal API or in Web API. We want really to just call that handler code. And because all that we passed over the wire were those parameters that were encapsulated in that object that came over and carry out whatever the action is, right? So if we do that, basically we turn it into a command or event, we can use our existing dispatcher to route the command to the handler and run some middleware. Right? So all message pumps look like this. The first thing you do is you get the message. That involves whatever your operation is in your particular transport for reading some bytes off the queue, right? Then you're going to translate the message. In other words, you're going to take those bytes off the queue and turn them into something you can deal with inside your application, a type of some sort. In Brightest case, you're going to turn it into our internal message type. You can turn it more directly into your actual request if you're doing it yourself. But you need to translate it somehow. And then you're going to dispatch it to a handler, right? You're going to say, what handles a message of this type when I receive it, right? So message pumps are everywhere. So when you click on a window in a GUI-based operating system, a message pump is dealing with that, right? So for any given window, you have a message pump running, which essentially says, get any messages in my queue, like a click message or whatever, translate that message, in other words, figure out basically from what I get on the wire, what this actually is in terms of something I can understand, and then dispatch it to a handler. So call a piece of code that I've written to handle this. So Windows, Mac, they all work the same way. It's basically what people think of as a reactive model, right? And then basically my dispatcher means my handler gets invoked and I handle the message. I may fail to basically deliver the message, so it never reaches a handler. In that case, I should write it to a dead letter channel. That's what they're for, right? That says, could not deliver this message. In other words, it's a bit like the postman eventually saying, return to sender n number of times, couldn't be delivered. Typically, that's also what happens here. It may get attempts to process it. Once you reach a certain count, effectively, it says undeliverable, right? You may get an invalid message. You'll see framework support for this much less, but theoretically it's true, which says I couldn't translate the message. It wasn't what I was expecting to see, right? Typically, someone misconfigured something and now I'm reading somebody else's messages. I don't want to throw those in the bin because it may turn out they were useful to somebody for fixing the damage of me reading the wrong thing. So typically I want to write them somewhere else. Often what happens is people just put them on the dead letter channel because I don't want to write two channels that I have to monitor for stuff, right? But theoretically, it's a separate idea. If I try and dispatch a message and I can't find a handler, you've configured your service wrong. Probably just write to the error log or even just terminate the application and say, this doesn't work very well because I couldn't find a handler for the message. And if you basically get an unrecoverable error inside your handler, write it to the error log. So what some people do here is they have an error queue and they write it to you. And it's a bit of a nonsense. It's like, you don't tend to have, when your HTTP endpoint for your post, if you basically generate an error, you don't tend to say, okay, make an HTTP call out to the error provider where I'm going to basically shove the full contents of the HTTP call that I received. You tend to just log it, all right? Or put it to telemetry. So just do the same thing. If it's unrecoverable, what I mean by that is no matter how many times you try this, it will result in the same error. If you have a recoverable exception, in other words, this is an issue that might go away with time. I couldn't talk to the database. Someone might fix that, and so maybe I could retry that because maybe the database will come back online. Typically, what you do is you re-queue it. Depends on the transport how that works. Some cases like SQS messages basically get locked. It's called a visibility timeout when you're processing them. So you can lock it for a certain window of time even though no one's processing it. And at the end of that lock, when that lock expires, it becomes available to be processed again. So a lot of frameworks use their locking mechanism as a way of hiding something for a delay period. So Rabbit does the same thing. Other things don't really have a locking mechanism you as a code author can use. So in that case, quite often you just delete it and put it back on the queue. All right. But that's basically saying, I think the error is transient and I want to retry it. And typically, you have to look things up in registries. So I've got a register of handlers for commands, a register of mappers for registries. And what that looks like a lot is this, right? So my message pump, which is that loop, reads something off the queue, and it says, okay, I've got a good message. I'm going to call my message mapper, turn it into an internal message type, or turn it into an actual request, basically, rather. I'm going to command or an event, etc. Pass that to my command processor. My command processor, effectively, or command dispatcher, will essentially then say, okay, great. I am now going to call my pipeline and execute the handler, and the middleware may run in between, like an inbox to deduplicate things I've already seen, poly middleware wrapping my handler, right? Middleware for telemetry or whatever. And only when I've processed that message will I effectively act back so that effectively the message is deleted off the queue, or I commit my offset into the stream so that I won't process it again. So you can see that the reason you see this synergy in many of these libraries between the idea of a dispatcher, right, a processor and dispatcher, not a mediator, but a processor and dispatcher, and messaging frameworks, is because typically our messaging framework is using that dispatcher to do its work. Okay. Dual execution. So long-running processes must survive restarts, handle retries and failures, and resume after waiting. So it's this idea of I receive a message and I need to process it. What happens basically if I fall over and die? How do I cope with that, right? How do I make sure that thing gets processed off the queue? Well, provided we don't act the message, which we described, basically until it's been handled, we won't lose work, right? Tends to mean our handle needs to be transactional. In other words, you don't want to half complete stuff and then fail and then have to redo that, unless it's an idempotent operation. Transactional, reverse it unless you complete all of it. If you're going to send outgoing messages, you're going to need to be transactional messaging. You're going to need to support an outbox. Handle retries and failures. Well, typically we've got some resilience libraries like Poly that we can use to wrap basically the code, so we can retry a few times, invoke a circuit breaker or whatever we need to, but we can effectively add some resilience in for jailbreak execution. And resume after waiting is basically a correlation ID, which kind of says I can send a message, right? And effectively I can then stick a correlation ID on it. And I can essentially then have a worker process which is waiting to receive a response. When it gets that response back, it will look in the message and say, oh, you've got a correlation ID for me. I will retrieve whatever it was that was uncompleted and update it, like a workflow or a state machine or the like, right? So with just that, you can get simple, durable execution. You don't need to pay for expensive frameworks or whatever to do it, right? Now, it can get more complicated, right? You can get into basically needing to have complex workflows, branching conditions, that kind of thing. And that's the point you tend to reach for something other than just this kind of poor man's durable execution. But you can get quite a long way with poor man's durable execution. When you get into, so mass transit has a saga. Lots of people deploy sagas in mass transit when they don't even need to. It's not doing anything for them because you could just have had 2 handlers and it would work fine. But you can get into genuine need of a saga when you start branching. Right? Okay, we're done. So, a question we asked at the beginning a little bit was, can't you just write this shit yourself? Do you not need? Surely there's no need for mediator. Surely there's no need for mass transit. I can just write the code myself and everything will be fine, right? And the answer is partially that the mistake people make quite a lot is writing software has never been the hard bit. Owning software is the hard bit, right? One of the mistakes we're about to see repeated again with Gen AI is generating code was never the hard bit. Owning the code that we create is the hard bit. And you can make a mistake where you generate a lot of code that you can't understand and you're going to achieve technical bankruptcy real fast because you can't actually maintain it anymore, right? It's about an order of magnitude difference, right? Really significant. So as soon as you know that, right, your first thing you want to say is, I want to write less code, not more. The less code I write, the less my ownership cost is. So I should only write code that I need, not other code. Right? So one of the things that helps you write less code is reuse. Right? If I can use this thing multiple times, I own less code, therefore effectively my cost of ownership is lower. If it's an open source project, even if I have some hand in maintenance of that project, if others are basically working on it too, then I have lowered my cost because other people are sharing the maintenance burden of that code. And it's being reused across many people, which is much more effective than me having my own inline version of what we do, right? What you're buying typically is a whole lot of experience across a community of how you solve given problems. Right. I don't think really until, particularly in the .NET space, a lot of the messaging framework people started talking about outboxes and transactional messaging. It was a really generally widely understood problem. Right. .NET is very good, particularly good at messaging frameworks. It's one of the reasons we push back on Microsoft writing a new messaging framework. Because in other languages, you will not find as good support as you have unparalleled choice by comparison to other ecosystems. Most other ecosystems, you're lucky if you get one choice, right? I said to the Java developers and work the other day, but where is your outbox for Maven? And they were looking at me blankly, all right? So that's one of the things we don't want to lose. But we have massive experience as a community of solving the problem. So if you write it yourself, what you'll typically find is I start out with something similar. It's worth as an exercise, you trying to see how they work. Writing some code to call Rabbit and receive messages from Rabbit, it's worth doing as an exercise, right? But you'll soon begin to stumble into things. Oh, what happens when basically I lose my connection to the Rabbit server? And it's in the middle of trying to post to Rabbit. What do I do about that, right? So all those things are issues we understand how to deal with because we've been doing it for ages, right? So then you might want to write outboxes, right? And then someone wants a different transport or storage provider. So where I work today, Just Eat Takeaway, there's a framework they've got in existence, Just Saying. Just Saying is a loose wrapper around Amazon SQS and SNS. The problem internally, the reason why we're switching a lot to using Brighter is not because I'm pushing it, it's because we're using other tools like Kafka and things like that, right? And the problem becomes this thing is fixated on one transport. So you want to switch transports, it's hard. Something like Brighter, sure, fine. Give me 10 minutes, I'll switch transports. Which gives you immense flexibility. But you yourself are probably not going to write for your own purposes something that could do that, because someone's going to say, yeah, but we're ever going to switch transports? That's never going to happen, is it, right? Until the day it happens, when everyone goes, why is it so hard to switch our transports? We had that conversation a few times. Sorry. All right. They're not up there yet. There's a couple of fixes I think I saw going through that need to be done, so I shall fix those. Some of these will probably get turned into some blog posts. As V10 comes out, we probably need to reinvigorate our social media efforts, because we've been quiet for a bit while we've been beavering away on stuff. And I may even have to do some YouTube videos, because that's what the kids seem to want, right? All right, any questions about this? Does that give you a better explanation? Sorry, I'll come in a second. Does that give people a genuine better explanation of why the answer to mass transit and mediator going commercial isn't just, oh damn, you, I'll write it all myself?
I just basically want to know, so the main benefits are what inboxes, outboxes, and validation.
The main benefit is probably, well, there are lots of, if you're saying, I accept the premise that I want to use a command-based approach to doing stuff, why wouldn't I just write flat command objects? The main advantage you get of, say, a dispatcher is middleware. The main advantage of using something off the shelf is we come with middleware, and we've done all the hard work of building middleware pipelines and everything else for you. But that is the major difference over just flat commands, is we provide you a mechanism to have middleware, which lifts out some of the complexity from your code.
Does Brighter come with like a thing to process the error keys? So similar to like Service Bus and Rebus and mass transit's going with the same thing with Service Bus with particular software stuff. Does Brighter have anything to kind of?
So we don't, because we don't recommend error queues. So we think error queues are anti-pattern. You just basically deal with exceptions the same way you deal with them if you got one from an HTTP endpoint. We could create something with dead letter queues, but typically actually your transport or broker comes with things to view dead letter queues and deal with them, right? So typically your main action with something in dead letter queue is to figure out why it was broken and then resend it. But we don't do error queues because they are not a useful pattern for messaging, because application errors belong to the application. If you stick it in an error queue, what is the difference ultimately between sticking an error queue and sticking it in your telemetry and then figuring out from your telemetry, shit, I need to do X, Y, and Z? Typically the action you want is not, oh, I just resend it. It's, I have to correct whatever was a problem that was the lack of this message caused. The only thing I ever see with error queues is people going, I got a lot of stuff in my error queue and I don't know what to do with it. We don't have that problem because we don't create error queues. You just log stuff and deal with it normally.
So do you recommend putting like retries on a lot of things?
So we retry basically, we tend to recommend retrying, yeah. Depends on your overall policy, because you can get retry storms where effectively you retry at too many levels, but provided you are effectively, say you're receiving a message, we recommend you do a retry. And if you basically give up on retry, you haven't act, so you just retry that message. If you don't act, the message has not been taken off the queue. So the only way that the only way that error queues ever make sense is I take it off the queue in an incredibly risky fashion, which removes basically the transactional guarantees I got from the message queue in the first place, and hope that I can write it to the error queue before I crash when there's an error. It's never going to work. All right. So error queue is just a fundamentally bad idea. That's why we don't support them. But I get it. I get people who are used to the idea of error queues. If you get an application error, then either it's a recoverable error, in which case just requeue, or effectively it's a non-recoverable error, in which case do what you always do and basically put that out basically via your observability, right? Log it or so that effectively whatever you use basically to process your logs will pick it up because you already have something for that. So why are you doing something that basically treats your error queue as an additional log that you need to also process? Dead letter queues are potentially worth pointing a tool at to reprocess it. But to be honest with you, that's easy. You can write your own, you could write a brighter application that processes the log, right? You just read from the log and run something in the handler. Doesn't need us to write anything. So we don't kind of believe in that format.
Yeah, I mean, we don't use priority where I'm at, but we have a lot of queue processing. We just use dead letter queues. We don't have like separate levels. It's just you give it X amount of tries, and if it fails, stick it in a dead letter queue. And either replay it or have something reading the dead letter queue to send it to telemetry that way. Yeah.
Typically, basically, you're unrecoverable, except that's basically a normal exception written to the logs. You're recoverable, you retry X number of times, and then write to dead letter queue. That's all you need as your options. And like I say, Just Saying has error logs, and the only problem people have with error logs is, what do I do about my error logs? How do I process them? And when we haven't got error logs, it's never a problem. Funny. Go on.
You say writer can be used in process.
So if you're basically doing, commands and events in process, A bit like mediator. We do have an explicit in v10. There is also an in-memory transport, which you can use if you're doing some kind of modular monolith scenario where effectively you don't want to be just a in-process call. You want to put it onto a queue and have the other side process the queue as a consumer. You can do that over an in-memory bus. We mainly use that for testing. The reason why we don't necessarily recommend that you use that is because it's in memory. So in the event you crash, you'll lose everything in the queue, right? So it's okay if you don't care, which you don't when you're testing. So most of our tests that basically work on the core libraries don't work with a particular transport. They work with our in-memory stuff. So you could use it for that, but I'd only use it if you're like, if we crash, it doesn't matter. We'll just resume and, everything will be good.
And so, there's no pathway from going from single process memory to a more distributed system.
Well, I mean, the easy way, right, is because it's just the same command processor, and effectively rather than calling send or publish, you just call deposit, post, and clear post. Well, the first thing you might want to do is just call post, right? Post doesn't require an outbox, just using an in-memory outbox. And that's an easy transition. And then you go, but I probably want an actual durable outbox. So then you need to switch that to be deposit, post, and clear outbox, right? And then you need to run a sweeper, which is mostly you can just get the relevant tools for your app off the shelf from Brighter and then basically run a sweeper in the background that says do that. So you can kind of transition through those steps if you need to. Yeah. I mean, it sounds easy, right? But obviously, so the main difference, to be honest with you, it is not that at all. It's that, generally speaking, the way you want to do it is you want to basically have one process that runs a pump that reads from a queue, and one process that writes to it. Generally speaking, when you end up with services where effectively you say, I've got my HTTP endpoint coming in and I'll put the pump on a background service, that isn't a great choice. And part of the reason that's not a great choice is they scale for very different reasons. One of them scales because of the number of HTTP requests I'm receiving. One of them scales because of the number of messages I'm receiving. And you're effectively scaling them both to have any effect. The other thing is, I am not 100% convinced every time I've tried that .NET background services work very well when you try and do it that way, because you've got this very busy pump that's reading stuff. The reactor and prototype we didn't go into, but I'll tell you just vaguely. So we support two. So the first thing to say is we do not use the thread pool. Why don't we use the thread pool? We don't use the thread pool because the thread pool breaks under load. So one of two things happens. Either you exhaust the thread pool or you put a limit on the thread pool and say you can only use X many threads, and when you use X many threads, don't use any more. So naive versions of these tools, what they tend to do is they say, okay, oh, I've got a message, get a thread from the thread pool, basically use that thread to run the handler. And I've got another message, great, I'm going to get tons of messages all going in parallel, I'm going to be super fast and efficient, everyone will love me. Right? What happens is though, you exhaust the thread pool as soon as you get enough messages. So everyone goes, well, that was a mistake. What I better do is write something that says you can have a maximum number of threads at that running at any one time and use a semaphore or whatever, etc. Typically people use a semaphore to do it, right? So as somebody exits, they will free up a thread from my governed number, right? Semaphores break at sufficient load, right? What happens is you start sending enough messages through, and what happens is it will just lock up. You'll lock up a basically context switching. So just for info about scale, so Just Eat Takeaway sends about 1.5 billion messages a day. Sufficient scale just stops fucking working, basically, all right, when you do that, all right? So Just Saying had that problem. So I had to show them how to fix Just Saying because it had that problem. It would run into a problem where it would just lock up at a certain volume. So Brighter doesn't do any of that, never has. Brighter says, right, I'm going to take one thread and I'm going to run my message pump on a single thread. And on that thread, I'm going to run both the pump and the handler, right? It's basically what COM calls a single-threaded department. It's the way most of your user interfaces work, right? Single-threaded department. And it says, okay, that way, that offers me a couple of things. One is it offers me guaranteed ordering. So if I'm reading from something like a Kafka stream, I will process those things in order because I only have a single thread, right? Second, if I want to scale, I would just explicitly say, I want another thread. And you can, so we call that combination of a message pump and thread a performer. And you just say, I want to have 5 performers, right? So you can figure that out for yourself from basically the characteristics of the machine that you're running on, how many you want to have. Nowadays, typically, people often have only one, and they scale out by using Kubernetes or the like to basically scale individual single-threaded message pumps, because then I can basically use Kubernetes to scale that number up or down. We do have support for scaling in Brighter, thing called a control plane, which we have, which you can use over HTTP, where you can send a message to stuff saying, increase the number of performers. It's old school because Kubernetes didn't exist when we wrote it. We still support it. Some people, for some reason, still like doing it that way. God bless. But I would recommend basically doing Kubernetes pods. So we have a single thread, very predictable. It also means we are much better at Kafka than any other messaging framework for .NET. Because the way Kafka works is Kafka says partitions, maximum of 1 thread can read a partition because you have to preserve ordering. And the way that you effectively scale is you basically say, well, I need to have as many threads running, for many consumers running effectively as I have basically partitions. And we can support that because effectively every performer can be a separate thread reading basically from a separate Kafka partition. If you try doing that with a thread pool, you get yourself in a mess because effectively your reader, Kafka just thinks of you as being one reader. You may be thinking, I'm doing a lot by using multiple threads. But really, it's deordering and using threads when Kafka thinks, well, all those additional threads are actually being used to read additional properties. So it doesn't really work for Kafka. And you notice things like mass transit. They include Kafka in they call a rider because their model doesn't really work for streaming processing. So we make a deliberate choice. So that's one thing that's very different about us. So we basically support reactor and proactor models, what we call them. So basically that's a sync pipeline or an async pipeline. And you can either say, oh, I want to handle my messages sync or I want to handle them async. Now, lots of .NET devs, unfortunately, have been very much trained to go, but async is better, Ian. Why would I ever choose sync? And the answer is because I want to be more performant, so I would choose sync. Async is always less performant. It shares your resources better. So it scales better to many people using the same machine, but straight line performance is always better from sync. So we continue to try and support sync, despite the best efforts of the rest of the industry to basically screw that up. Like RabbitMQ version 7 now only supports async from its client, right? So we now support both 6 and 7 from V10. We'll support both the old library and the new library, so you continue to use sync. We will do sync over async for you, right? So we have our own synchronization context. SVNet dropped theirs because it's a pain. We actually dropped kind of most. We kind of rewrote ours to basically be Steve. We just borrowed Stephen Cleary's code, right? So we acknowledge that as our acknowledgement term for his sync context, because our old one was based on some code from Stephen T, but it was creaking around the edges. So that's another change in V10. We changed our sync context engine. And essentially what that means is that even when we are running async, we are still single-threaded. It's the guarantee we make to you. So we will basically run async on the same thread. Some people go, how does that work? Well, because async blocks, don't forget, right? Async is not non-blocking. But async basically just says, when I block waiting for I/O, I will hand the thread back to somebody else to use effectively. And when the I/O is signaled it's complete, I will get a random thread from the thread pool instead. We just don't give you back the thread. We just basically say, no, that's our thread. We'll block and wait for the I/O, but we're not about sharing our long-running thread with you. Thanks very much, right? So effectively, the only difference you'll see is that we therefore share execution for the point of view of a scheduler on the machine better. So someone else can schedule another thread to run instead of us, because we're saying we yield, but we don't give up our thread. It's ours. It's a long-running thread. Go and find your own thread, because it's meaningless, right? Thread is just a virtual idea, effectively, in that process. So I can't really surrender that to anything else. We're not running a thread pool in the first place. So there's no one for us to give it to, effectively. Right? So there's some complexity there, but it means that we have some predictability that others don't have, because you can always predict what we're doing, but it does mean you have to use a little bit more thought than others have, because others kind of hide all those choices from you, whereas we say, you're big and you're smart and you can figure it out. But, anything else? If you haven't used this yet, I'd wait a little bit and use V10 when it's a bit more stable, rather than starting on V9. That's what we'll probably push to people, because mass trans doesn't go to commercial until middle of next year, so V10 should be stable. The other thing is there are some things in V10 that are, if you like, because we tend to put stuff in, so we don't have to, based on our plans, so we don't have to keep revving major version revs. So you won't see everything that's going to be in V10 on V10 launch, because some of it gets built later. One of the things we've got, which is new in V10, we didn't have before, is scheduling, so that you can do it where you saw us doing command, send, and publish and post. You can do at a specific time or after a delay, and then we will use Hangfire or Quartz or AWS scheduler or whatever you configure under the hood to basically delay that command happening. And part of that is there, not and is a useful feature on its own, but we'll probably introduce a kind of lightweight workflow at some point this year, so that those of you that don't have, because I don't really like sagas. I think in mass transit, I think they're really badly implemented. I don't think they give you what you need. I think what you need is basically lightweight workflow, because there are 5 basic workflow patterns, like sequence, join, split, merge, and the ability to enter a kind of waiting state, waiting for an operation. So we're going to give you a embedded, resumable workflow engine, so you can do that instead, which is much more what you really want than a saga. Well, not a saga, a state machine, because that isn't really a saga, it's just a state machine they offer you, right? So we'll give you that later in the year as well. And that means we would probably be feature parity, well, A, with mass transit, but also B, with Dapper, DAPR Dapper. So that's, I care more about what Dapper is doing, because it's a CNCF standard than what mass transit is doing, to be honest with you. So we'll also support cloud event. We currently don't support routing on cloud event type. We assume that your channel has only a single type, which is what's called a data type channel pattern, which is the sane way of doing shit. But some people want to be insane, including some of my colleagues at Jet, and they want to have different types on the same messaging channel. And cloud events type is metadata information. We'll give you that. So we've got much better support for cloud events in V10. And we will also, before RC2 or RC3, before we're final, introduce something that lets you route on that type. And we'll throw in what we call an agreement dispatcher for free, which means that rather than the dispatcher as it works today, just saying, run the middleware, execute the handler, and to answer your question, it will also say, run the route according to what I give you as a rule. So the basic if you don't configure it, it'll just do what it does today. It will basically look at the type of the command and then register the handler of that type. But we'll let you configure it to have a rule based on the contents of the request to pick a given endpoint handler. And that lets you do scenarios like, up until this date, it was this accounting rule, now it's this rule. So things before this date should get routed here, things after this date should get routed here. So we'll give you both of those because that lets us solve some more complex problems when we come to do things like workflow.